Thanks for joining us, everyone, as we welcome Chris Crowley. He is going to be talking to us about all the things that he knows. He's a very smart man, he says. So
I don't know. I didn't say I was smart. I said I knew some things.
You knew some things, right? All right, Chris, we are going to give it to you.
All right. It's mine now. You've given it to me. Let's go. So I want to talk a little bit about security operations centers. That's what that SOC refers to. Architecture maturity and some common failures. A little bit about me, in case you missed it in the pre-component of our talk here. Basically, I started working in computers when I was 15 years old, which was a long time ago. And I had this job where I actually applied to it, I think, when I was like 13 or 14. And they didn't hire me the first time. But then the next year, they actually contacted me and they're like, hey, you came in and interviewed for this job. We'd really like you to come back and interview for it because we're about to list it again. And they said, we couldn't really bring ourselves to hire like a 14-year-old kid when you applied to this job the first time around. But I literally ran tape backup. And it was a shop that did a lot of, they used a lot of digital equipment, computers. It was actually a fascinating place. I worked with a whole bunch of like computer nerds who had left Bolt, Beranek, and Newman because it was getting too corporate. And by the way, this was like in the 80s. And so basically all these computer dudes just decided like, all right, we're gonna move out of Boston and go out to this this suburb of Boston and work at this place. And this place actually developed an open source software package in order to do integrated circuit design. And we actually had a fabrication facility for building IC chips. It was a photolithography facility. And the software engineers would work on the software, and then they would deliver this software to the various universities throughout Massachusetts in order for the hardware engineering students to do their like master's thesis and PhD work in order to be able to design integrated circuit chips. And then they would send the design to this place. And then we would build the chip at our fab facility, like one-off IC prototype chip construction, and then send it back to them in order to do testing. So that was what I did in the evenings after high school, is I'd go to this place and like log in, sit around by myself, cruise the what was the internet at the time, which was basically NNTP and FTP, and basically just like go into all the computers and read all the stuff that I could possibly find. Right. So that was my formative years, which is probably why I'm as weird as I am. Since that time, I've worked in a lot of different places, educational organizations, software development firms, financial institutions, the U.S. Department of Energy, U.S. Department of Defense, telecommunications providers. Basically, all of this stuff formed my brain in terms of my thoughts about what I think should be done in terms of cybersecurity. And I have tried to condense all of that into this thing that I now call the SOC class. It was Management 517 at SANS. SANS actually retired it. And I've got a blog post out there if you want the backstory on that, but I'm not going to go into that now. And so I have re-released it independently. I also still continue to teach for the SANS Institute, SEC 504, SEC 511, SEC 575. Maybe those numbers mean something to you, maybe they don't. The idea is that I have a very broad spectrum of experience, capability. I've got some pretty strong opinions on the way that I think that things should be done in terms of security operations. But also, I think that it is all contextually dependent on the organizations and what they're trying to do. So let me give you a little bit of insight in terms of the background information, and then I'm going to talk about what I see in security operations today, some common failures, and some aspects of what I think people should do in order to address that. I want to start with the notion of threats. And there's a tremendous amount of threat intelligence available. And for me, when I'm talking to people who are making decisions about cybersecurity, it all boils down to this. This is actually an adaptation of a graphic, which was the executive summary graphic number 1 in a paper that was written by the United States Department of Defense Science Board. It was Resilient Military Systems and the Advanced Threat. And you can basically download this. You can find this. This neatly summarizes the threat to every organization in the world. Now, the DoD cares about their stuff, but they're basically saying this is the category set for threats. There's the $1 billion club, the $1 million club, and the $10 club. And this is what all of this massive body of threat intelligence can be summarized into. Before you get upset, I'm not saying that threat intelligence has no value. I'm starting with this depiction of what threats are, because this very neat, coherent depiction of threat intelligence is something that everybody in your organization should actually understand. And if we're talking about cybersecurity and you don't have this baseline fundamental concept of what you're fighting against or defending your assets against, then you're not off to the right start. So let's get off to the right start. The right start is we have the $10 club. The $10 club is capable of reusing vulnerabilities which are provided publicly. That's what the $10 club is. Now, the $10 club actually causes us massive, massive problems. Okay, all sorts of issues coming from the $10 club. But really what they're doing is they're reusing stuff that's already been made public. The $1 million club is capable of discovering vulnerabilities. They have the time, they have the resources, they have the people, and it takes millions of dollars in order to do this in some case. But that is the scale at which they are actually operating. And then there's the $1 billion club. And the $1 billion club is something that is funded to the degree that they can use, and the terminology from this Defense Science Board report I really like, the full spectrum of possibility, full spectrum of capability, which means if it's physically possible, they'll build it. It means if it would be the easiest and most cost-effective and efficient and economical thing to do to break into someone else's resources and just reuse those, they can do that. It might be useful to just bribe people in the target organization. They can do it. You need a device driver signed in order to be able to install something inside of a target environment. $1 billion club, they've already got that, right? They have been developing this capability for an extended period of time and are able to use whatever physical things are possible in order to accomplish whatever their objectives are. The $1 billion club creates vulnerabilities. The $1 billion club is everywhere and essentially constantly striving to advance their position and mission objectives. $10 club is including the $1 club. That is you go find some stuff and basically go and attack some things. That would be you in the $1 club. In terms of talking about SOCs, I have a reference architecture that I basically advocate. It is useful to me and useful to most people to be able to articulate this in terms of functions, in terms of capabilities. So the first one for Security Operations Center is a steering committee. And this is not really inside of the SOC. It is more derived from the constituents of the SOC. But if you do not actually establish this bidirectional communication from the people who are your constituents back to the people who are doing the defense, the defenders are going to miss important things. And the people who are supposed to be defended are basically in a position where they do not have a voice on how they would best be protected. In terms of the command center, this is the interrupt receiver. This is the communication out from the SOC, and also keeping the SOC on track. Monitoring, threat intelligence, incident handling, forensics, and self-assessment. These are the components that make up a SOC, and I'm going to talk about all these in a little more detail. I think that the steering committee basically has three phases. That is how it works. In terms of the link, Radis, you can go to the montans.blogspot.com and it's on there. Just do a search on that site in order to basically MGT 517 on that montansblogspot.com for that information. In terms of the way that the steering committee functions, initially there should be some design phase. And this is What are the things that we think represent success for the SOC? And this statement of success eventually should be a manifest in metrics that are delivered to the organization. I've got all sorts of stuff that I've written about metrics. I'm not going to go into the details of what those metrics look like here, but if you want to do a montans.blogspot is the URL to grab that blog entry for the sort of historical stuff for it. Design is, what are we trying to address? And design really might be like, we just need to make sure that we need to do this one particular thing in order to do our CYA, in order to set it up so that our organization is meeting all the legal obligations that it has. Okay. And I mean, that literally might be the design. And they probably won't be so forthcoming with it like that, but you can usually figure that out. Build then becomes the actual deployment of the details of what's actually going to happen, where we're going to buy technology, we're going to hire people, and then we're going to pull all this stuff together and make it happen. And then the operations is the ongoing operations of this. And what the steering committee does in this regard is helps to express their initial concept of what this should be. Then they make sure that, oh yeah, it looks like you're on task for what we think we need. And then they are the place where we go back and share information to, so that we make sure that we have some guidance on us doing the thing that needs to actually be done. I have seen steering committees as actually like really structured voting type thing. I have seen steering committees where there isn't really any voting, but there is some sort of formal membership that actually occurs on it. I've also seen this sort of like strategic decision makers and tactical implementers on this. And so the last part of this is this ad hoc. I've seen this most often. Ad hoc structures suck in terms of actually having consistency of direction for your SOC. This is very frustrating, where different people are telling you different things depending upon the day, week, hour, phase of moon, whatever it is. Okay? That's not a good way to run a SOC. I also think that there needs to be some way to articulate what it is that the organization thinks about damage that it experiences. And here's one example. This is a way that I actually build this out. It's basically this depiction of a numerical sort of graph on a per system basis on what the organization expresses is the importance of this system based on functional, informational, and recoverable components of the system. And then on a 1 to 10 scale, we will say this system, the function of the system has a 1 to 10 value. The information contained in it has a 1 to 10 value. And the idea that we could actually recover this has a 1 to 10 value. And then we will have low, moderate, and high rankings. And then this is actually agreed upon with the steering committee and then delivered to the SOC, so that when the SOC has an incident that they're observing, they can say, well, this is system X. Let's pull up the depiction for that particular system's importance. And then what we can actually say is, based on the guidance, we think this one's a moderate impact related to the function of the system, a low impact related to the information in the system, and a low impact in terms of the recoverability, because we can recover with stuff that we have on hand. So we have a quantitative expression of the damage that has occurred in this moment, in this system at this time, in terms of this incident. And if you do this, now all of a sudden we have a way to quantitatively express what the problems are in the organization over time. And so I see somebody asking roles I see on a SOC steering committee. These are all of the system owners should have representation. So if you have people who own systems, I also will tend to see C-level sort of chief information security type people or their representatives. And the idea here is that this is the representation of the organization's interest in that. I will mention this again at the end, but if you go to this link that I'm about to put in here, mgt517.com/SOC, I have probably another 20 presentations with all sorts of documentation and details around like this sort of stuff. So you may need to poke around a little bit in there, but you can probably find a toy org chart about what the roles are that would be on the steering committee. Right. I don't have it in here, but you can find it in that resource of stuff that I've released publicly that's available for you to take a look at. But that's a good question. Like who makes the steering committee? The next thing I want to talk about though now is what these different functional components are. Now, I'll get to this in a moment, but you may not like me talking about this in terms of functional areas because that's not how you organize your teams. And I totally understand and respect that. But for me to be able to explain this, right? For me to be able to explain this, I need a way to talk about it. And the most efficient way to communicate it for me is the functional component model. So that's how I'm going to depict that. The steering committee is the first one. I also talk about software and hardware to make a SOC, the structural arrangements of like what this oftentimes looks like in practice rather than this sort of theoretical depiction of this, interactions between the SOC and the constituents, processes and the effective operations and orchestration and automation. These are all things that I actually speak to. It's just that in order to give you a very digestible 1 hour depiction of this, I need to sort of get it down to this model, which is really nice because then when you don't need to go into all the details with people, you can actually depict the model and say, well, here's a nice, complete depiction of what's going to happen. But we also have the details behind this of all the other aspects of what's actually going on underneath this. And so you might have stuff where it's like you combine your command center and monitoring teams. Fine. That makes a lot of sense in some ways. You combine your incident response capability and your forensic capability. Again, like makes sense for the combination, diminishes the ability to specialize, but makes sense. Threat intelligence and self-assessment. And again, these are my shorthand for the different teams. But this is the component of what I see people tending to combine. But you can combine them in any given way. You also might just have a pool of staff who does all these functional areas, and you've got 5 people who are trying to cover all of these aspects. That being said, you need to also think about the outsourcing arrangements that you have and what parts of your SOC are actually outsourced to some third party. All of the SOCs which I have ever encountered are doing essentially these functions, which is why I've decided on this structure and labeled them this way and depicted them this way. Okay? So the first one is the command center. To me, the command center is like the layer on the outside of the SOC that doesn't allow people to break into our limited resources and tell people what to do. It also becomes the telephone number to call. It becomes the sort of the emanation of status information coming back out. This is basically the verification, escalation, triage aspects of the SOC. This is deconfliction of incidents. When we get reports from 10 different people about a thing and they're reporting it differently from their perspectives, we need to, in the command center, make sense of all these varying reports and say, okay, these 10 different reports are actually all related to the same incident, except for that one. And that one's a different thing, right? So we've got 9 things on the same subject and one that's different. Now we're going to basically split our incident response based on the priorities of what we're seeing. And so this is a triage or deconfliction, depending upon whether you work in the medical community or the a military community. Those are where those terms tend to come from. And so command center's overall objective is maintenance of situational awareness, maintenance of the operations of the SOC. And I actually would call out a sub-function, probably of command center, of the actual IT operational aspect of that. So there's a question, would that be like the ticketing system? The ticketing system is a technology that the command center and other aspects of it are actually in use, right? In order to be in place. Ticketing systems and technology. That is the use of this. There's a lot of care and feeding that you need to do for the systems themselves. And so the operational aspect of it is basically a way that this will be run by somebody. You may outsource it, but somebody needs to handle all of the infrastructure. And so monitoring is something that oftentimes gets matrixed in there. And so Braindance, the first slide that I depicted with all the different groups actually has the functions. When you download the slides, if you look at that first graphic, you can actually see command center, monitoring, incident response, and so on. And so monitoring is the thing that a lot of people think of the SOC as, is just they watch for problems, they identify the systems that we're supposed to be defending, and they look for anomalies which are suggestive of issues. And the problem for monitoring is that they have this massive volume of constantly changing data, and they rarely have good insight into the aspect of what they're supposed to defend and what the organization actually cares about. And so their responsibility, their function, their objective, their mission is the fast and accurate detection of issues. Threat intelligence, we have this notion of insecure systems being impacted by threats, right? I mean, it's like if you had a completely insecure system and there were no threats, that insecure system would happily churn along and not really have any problems. And so threat intelligence is actually something where if we understand what adversaries are more likely to do in order to accomplish their objectives, we can deploy our minimal resources in order to be able to actually defend those assets, so that even though we have weaknesses, we're defending against the things that they're doing in order to be successful. And so then we can stop them from being successful. And so this really comes down to our notion of these are our systems. We should know this, right? And threat intelligence is in place to help us to retain that home field advantage. Threat intelligence might consume threat data, which is, the threat feed, but threat intelligence should help us to consume data that's actually useful and relevant. They also might produce threat intelligence, which is by studying intrusions into our environment. This is an aspect of the intrusion, something that we can learn from it becomes threat intelligence. I see a question about 49,000 registered patents in the domain of AI-enabled SOCs. I actually have a specific talk around orchestration and automation. And one of the things that I talk about in that talk is the paradox of automation. And the paradox of automation is when we get better at automating things, we end up with difficulty resuming from problems. And so that is something that we actually will see more of going forward. And I predict that we will have some catastrophic failures in SOCs, which are AI driven, which cannot easily be recovered. And there is a full sort of crash that happens for some period of time. But over time, there's a lot of automation and orchestration that will actually end up being driven by artificial intelligence, machine learning, and so on. And if you want more details on that, go look at the January of this year, SOAR Austin talk that I did where I talk about orchestration automation. And I see machine learning and artificial intelligence as just an extension of the orchestration automation actions. Another thing that I think is absolutely necessary as a function in a SOC is the idea of incident handling. Incident handling is the dealing with problems once they've been identified. This identification might come from our own internal monitoring. This identification might come through the command center for notification from an external component. The idea of incident handling is an effort to minimize the damage from the incident. Part of their work is to determine the extent of the incident and then assist the organization to return things back to a normal state. And so incident handling has as its objective the minimization of impact. And I actually have sort of a cynical opinion in many ways about incident handling and incident response. So I talk about three different characters, or I oftentimes say caricatures of incident response. The first one is janitorial services. Low cost, routine, clean up the mess. We're going to have messes. That's okay. We understand it. Low cost, routine handling of cybersecurity incidents. The next one is the one that a lot of people think of when they talk about incident response. And these are firefighters This is the idea of intervention during the incident. In order to actually have intervention, you need to detect it while it's ongoing, right? And fortunately for us, or unfortunately for us, adversaries actually tend to operate unchallenged for weeks or months in our environment. And so you may actually end up with plenty of opportunities to do firefighting because the attackers are there for an extended period of time. And then my third character is the apex predator. High performance, the ability to differentiate the very effective attackers early on in the attacks in order to be able to actually decide, you know what, I'm going to do watch and learn on this team to see if they're bringing anything new to our environment, because we have adequate threat intelligence to be able to understand that this is that particular threat actor back this time. That takes a tremendous amount of work. It takes a tremendous amount of resources. It takes well-trained people. It also takes coordination with the janitorial services and the firefighting in order to make sure that they don't screw up the stuff that the apex predators are working on. And so this is something that I think a lot of organizations fail to understand, that this is their repertoire of incident handling. Janitorial services, firefighting, and eye in the sky, apex predator, advanced persistent threat, whatever you want to call it, type interaction in incidents. Forensic analysis is another thing that's actually really quite important. And if you cannot do forensic analysis, then you will not be in a good position in order to do incident handling. And so for this idea here is that forensic analysis has actually several different subdomains of specialization: host-based forensic analysis, network-based forensic analysis, reverse engineering, and e-discovery. And I will talk about each of these here in a moment. But my function of forensics is defined as the ability to do detailed and authoritative analysis on assets. And this can be deep dive and authoritative on the host, where I'm looking at the details of a mobile device, in the cloud, a workstation, whatever it is. The forensic analysis that gets done answers a specific question using all of the different components that's available to it. Here are some artifacts. Tell me what happened. Did Chris steal the leads? Did this data get exfiltrated? Tell me, based on the file system on this host or based on the logs on this host, what happened. Similarly, on the network, we look at all the switch firewall, proxy logs, whatever you have available, the SMTP logs, and all the other logs, and full PCAP if you have it, in order to make an assessment of what happened. And reverse engineering is another aspect of this, where it's actually incredibly useful, but so complicated in the component of what we want to look at. But being able to do reverse engineering, if I can take a host-based forensic collection, memory collection, or file system collection, and then turn over an artifact that's discovered as an unknown program, and then have someone actually assess that and depict all of the capabilities that are present in that particular piece of software, then that really advances my forensic analysis in order to then be able to say, okay, well, here's what they're using as a back channel because it's programmed into this program to be able to use this specific command and control channel. And this is how they were exfiltrating data. Another component that I put inside of forensics, which I think that many organizations fail to anticipate the need, is something called e-discovery. And I will tell you, if you already have e-discovery in your organization, do not fight to bring it into the SOC. If your counsel, your general counsel, your internal counsel, your human resources, or some other portion of the organization is already doing this, don't fight to get control of it. But if you are building a SOC and you don't have e-discovery, then you need to anticipate the need that e-discovery is going to come up at some point in the future. And so you are essentially reusing your security tools in order to perform a legal requirement that the organization will probably encounter at some point in the future. This is management of and appropriate retention of data. This is searching through that data in order to be able to collect and deliver components of the data that your company owns and retains and manages. So be ready for that. If you're building a SOC for the first time, build in the technology to be able to actually deliver that, but also realize that there are going to be specific constituents that you're doing this for in order to actually satisfy legal requirements which may be delivered to you. And then I have, as part of the SOC, the idea of self-assessment. And so for self-assessment, I actually bundle in configuration monitoring, vulnerability management, pen testing, and development of exercises. And all of this is intended to align the ongoing IT operational components of the IT systems to provide oversight from within the SOC to assure that things are being done as effectively as can be done. And so configuration monitoring is change control, baseline development, monitoring file integrity, developing application whitelisting, creation of approved standard configurations, tracking deviations, monitoring the systems that are currently deployed for change identification, which can be an incredibly powerful detect in our standard monitoring capability. But this configuration monitoring is specifically designed to making it so that systems are very obvious when they've deviated from the norm or the baseline. And so if you have a good way of doing configuration monitoring for IT operations, baseline IT operations, all of a sudden unauthorized change is detected really quickly. Vulnerability management is the differentiation of systems which do not actually have patches which are already released. We use a technology of a vulnerability scanner. The problem that I find in vulnerability management is people think that they get points for just running the scanner. That's not what matters in vulnerability management. What matters is getting things patched. And so this is the identification of the attack surface of systems and driving change in order to make sure that weak configurations or possession of known flaws do not actually allow us to get compromised. Penetration testing takes that a step further. Penetration testing identifies things that are problematic and then demonstrates the impact of what an adversary would actually do with that. And this is something that's super time intensive. It's incredibly difficult to do well. But the point of pen testing is the determination of the risk of an information system if an attacker actually got in there. And so what I have found in my experience is that if I say to an organization, patch MS blah, 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 it falls on deaf ears. However, if I can come up with some specific artifact that shows that I was able to accomplish something that the organization would consider damaging, then all of a sudden they're like, well, how do I fix it? And it's like, well, apply patch MS blah, 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 like I already told you to do, right? And so organizations don't tend to change their posture until they've experienced some damage or they've experienced some simulated damage. And so what I want is for the pen testers to actually be part of the SOC in order to create this internal antagonism of, I'm getting through. Are you all seeing this? How can you not see this? Right? And I can actually talk about this for the notion of SOC analysts. But if I can put someone who has pen testing capability and put them with somebody who is a defender, then I think that will drive change substantially more effectively. And so there was the idea of blue team. I saw it scroll by on the Discord. Blue team to me is a label of the defenders. Okay, and so the blue team, a lot of people will say, well, this is the monitoring aspect or whatever. All those labels, that's fine. I'm talking about these functions to depict it. If you want to overlay colors on top of who does what, it's probably not going to be an exact match for this. And actually, Sean's saying this presentation helps identify high-level gaps in an existing SOC. Hold on to that thought because I'm actually going to show you specific tools that will allow you to actually do that specifically. And I'm going to talk about 2 ways where you can actually do analysis of the maturity of a SOC. And it maps back to the things that I'm talking about here, but there are 2 specific instances of maturity. So just sit tight for that because this is what I'm getting to. It's like once I give this to people of like, here are all the functions that you need to perform, oftentimes they're like, whoa, that's more than we thought we needed to do. And it's like, well, yeah, but if you don't do these things, then you're going to have a problem. I also, and again, I don't have time to talk about it today, but I have a whole bunch of stuff where I talk about the notion of what sort of support functions you need in an organization and how to interact with them. And this includes human resources and legal and IT and the other aspects of support in the organization. Because the SOC's doing something, and if they don't have that sort of good rapport with the other parts of the organization, you're going to be inefficient. You can still do it, but you're not going to be optimized in terms of your capability. And so developing exercises is something that is way too often neglected. in this space, the thing that a SOC is supposed to do is have some things which are very procedural and routine, but a lot of what we do is deal with things which are specifically not routine. And if I'm tasking someone on doing things which are not routine, then what I need to do is train them for these types of scenarios that they might encounter and keep refreshing that training so that when they encounter a scenario that's kind of close to that, then they can adapt their learned responses into that deployment at that time. And so the culture that I find in a lot of organizations is, look, we're too busy to train. And I'm like, no, you're not. Because if you're that busy, you actually need to be improving in order to push the routine things away and get to the things that you actually need to do in terms of actually performing analysis. A lot of organizations expect improvement, but don't allocate time in order to retrain people for improvement. And if I say to a SOC analyst, like, hey, I want you to get better, they're going to throw up their hands in disgust and be like, yeah, well, when am I supposed to do that? And how am I supposed to accomplish that? So I actually need some people to be able to help the analysts who are doing the work to make themselves better in line with the work that they're doing. And this actually requires some investment of the organization in terms of time in order to make this work. The best way to make this work, in my opinion, is to find a person or a resource to help to start to build training internal to the security operations capability, 10, 15, 30 minutes a day of here's some challenges, here's some thoughts, here's some tools, here's some practice things so that you will get better over time. And my favorite example of this, and no surprise, I have another talk where I specifically talk about the idea of training. So I'm actually going to throw a link to my YouTube channel in here, and it's kind of predictable. But I actually have in that link that I just put up there for the YouTube, I have something that says EDUCAUSE long version. It's like an hour and 40-minute long talk that I recorded of my approach to training and the ideas that I have about what it means to actually train within a SOC. You can take a look at that talk if you want some more thoughts on the exercises. So as I mentioned a moment ago, a couple of things that you can use in order to assess the maturity of the SOC. First one I'll talk about is the SOC CMM. The SOC CMM is something that a guy by the name of Rob Van Oos wrote. And I actually found out about the SOC CMM after I had written my class. It was really interesting because I went and found it. And as soon as someone mentioned to me, I was like, man, this thing's worth a tremendous amount of money. And they were like, yeah, and he released it free and open source, and you can download the spreadsheet. He's actually now at a second major version, and I'm in communication with him occasionally, and I do a review of the SOC CMM. And so you end up with this 5-domain spreadsheet to go and assess the performance of the SOC. And then it gives you to assess the capability of the SOC. And then it gives you this maturity model. This does not do a live assessment. This does a paper exercise of what do you self-assess the capability in order to be able to do these specific things. SOC CMM is a super useful tool. And it's pretty funny. I've talked to several people about this, and I've had a bunch of people in my class say, it's interesting. We paid X accounting firm to do an audit of our SOC capability. And we basically got a report a lot like this, and it cost us $250,000, right? So the spreadsheet, basically, if you want to do a self-assessment of your SOC maturity, this is ready to download. And I saw that somebody just posted the link. Amazing, like super amazing resource. The next thing I want to talk about in terms of SOC maturity is actually the attack framework from MITRE. And I've got a couple different things to talk about with this. So first off, I know everybody has heard the attack of framework from MITRE, and it's probably part of your drinking bingo in the Discord now. Anytime that anybody says attack from MITRE, you need to drink, I guess it's before 5, so you drink your coffee. Basically, they've got this thing that sort of looks like a square or a diamond if you turn it on the side. And they say an adversary group uses a technique and they use software. Software implements techniques and techniques accomplish tactics. Okay, this is the basis of all the data inside of the attack framework. Okay, this is their schema. They talk a little bit about IOCs and how they think that their behavioral analytics development is something that moves away from specific items and basically now becomes a depiction of the software being used in order to accomplish some tactic. And so they're trying to move away from, individual IOCs and move toward an overall accomplishment of inspection of information in order to be able to understand what attackers are doing. And they're actually providing tremendous amount of resource in order to actually do this. So someone's saying you wish your management would come to these sessions. I actually have a 2-minute, so rather say this, I have a 2-minute depiction of the functions of a SOC on that YouTube link that you can share with your management. Tell them, look, I know you're really busy, but you should see what this person is describing in terms of a SOC. There's a 2-minute version of the functions so that people could actually, I could do a haiku too if you want, but 2 minutes is what I've got on a YouTube video in lieu of the haiku. In terms of, if you go read the MITRE attack paper that was written in 2018, they say, here are the expected uses of how you would use the attack framework. Adversary emulation is one way, red teaming is another way. Building out these behavioral analytics in order to be able to assess what attackers are doing. Build out a gap analysis. Take the matrix, identify the cases where you think that you can defend or you have high confidence that you can defend or you can't defend, and then use that defensive gap analysis in order to perform SOC maturity assessments. And so this intelligence enrichment, they talk about all these different things in the white paper, and this is how they expected people to use this content. And so they talk about the idea of this, and they say, build out your depiction where you have high confidence. And to me, if you're actually going to assess high confidence for something, that means you have a way to actually depict that this is the state of identification on a given use case for whatever it is. And then I have a detect where I could trigger the action using some of the software or using one of the techniques that the attacker is supposed to do. And then I can point to the corresponding action in my SIM or log correlation engine or whatever it is, and in terms of high confidence, and identify that my analysts actually act upon that within the time that I have as a performance objective. And if you can do all of that and depict that, then you can express high confidence. Otherwise, to me, like if I was actually assessing your SOC, and you're like, yeah, we've got high confidence. And I say, okay, well, show me your test harness for how to do this. There are a lot of circumstances where people will just be like, what do you mean test harness? How are you actually depicting that? This is a circumstance of self-assessment. And actually, I see Extreme Paperclip asking a question about, will your bosses be insulted if you did a self-assessment? I don't think that they would be insulted, but just realize that you might be, poking somebody in the eye if you go and basically say, hey, here are all the things that I've identified as wrong in this place. So you might actually sort of ask the person if they want your opinion on it and then share it rather than dropping a report on there that's a damning report that says, hey, here's all the stuff that we're terrible at. This is actually a talk that I think that you should go and listen to. This one is Andy Applebaum, who works for MITRE, who did a talk at the SOC Summit last year. And he talks exactly about how MITRE takes their own attack framework, goes out to customers, and then actually does these SOC maturity assessments. And so what they said is we take our enterprise matrix, we do our defensive gap analysis, and then with that defensive gap analysis, we provide, based on the threat intelligence information that's already built into the attack framework, we provide a suggestion to the customer of where they should focus their improvement effort. He's like, this is how MITRE does this when people ask us to do this work. That's another really good talk in terms of assessing maturity. You could look at SOC CMM, you could look at MITRE attack, make a decision about which one is the better way for you in order to assess your maturity, and then move forward with that. And basically, this is a 1-year type effort. You're going to take 3 months to do this assessment, even if you're just doing it as a self-assessment. And honestly, I would say do it as a self-assessment first for a lot of organizations. A lot of people want a third-party objective, and like I get that. I totally understand that. I do that to help people and all that. But start with the self-assessment and then say, do we think we got it right in terms of these objectives? And when you go to your management, they may say, well, we want a third party. If you're asking for all this money to go and fix these things, say, okay, we've already done this. Can we agree that we reuse the stuff that we did? This is basically my summary section on the things that I've been talking about here in the last 45 minutes or so. My summary section essentially is the idea of all the things that I've said. I love talking about failure. I love talking about failure. Why? Because this is something where I can articulate where things went wrong, and hopefully somebody will listen and say, you know what? I'm going to make a slight change so I don't experience that failure. So the first failure that I see, and I see this a lot, is no vision for the architecture of what the SOC needs to be. And you might actually disagree with my reference architecture. And if you do, I actually want to hear that, because in my opinion, your disagreement with my architecture is something that is really useful. Grayson says, what type of self-assessment are you talking about? I actually had 4 different subsections that I talk about with self-assessment. So look at those, and basically it's configuration monitoring, vulnerability management, pen testing, and development of exercises. With this, if you have a different reference architecture, then you probably haven't made this mistake. Because if yours is different and you've depicted all the different things that you think that you need to do, well, then you're already in a really good position to refine what you're doing currently. And so the failure that I see is the no vision on the architecture of the SOC. So this is something that is really important. This is our plan. This is our overall entire strategic plan of all the things that our SOC is going to do. And if you do that and you have some sort of review within the team and within the people who you're interacting with, then you probably will get some good insight in terms of what will actually be effective at moving forward. And even if you can't implement all of that architectural stuff initially, at least you have it stubbed out and you're not missing the interactions with this. Another thing that I see as a failure is no steering committee. Almost nobody that I've talked to in terms of their SOC build out actually started with the steering committee structure. And when I talk to people about this, it's rare that they say that they did it. And so it's like, why would you start with wiring closets in tier 1? Like, how does that even make sense from an IT project? This is just another IT project, and it's actually a low-level integration with all other IT that already exists. Like, you really need to get a lot of people involved in this. And unfortunately, we don't get a lot of people involved in this because we say, well, that's just going to slow down the whole thing. We need to get this deployed in the next 6 months. That's actually totally wasteful. That is the wrong approach, in my opinion. I can move fast. I can be effective in a short period of time if I have the right people and they all understand that this is the objective. Quick question from Grayson says, can I speak to the idea of outsourcing? I actually talk about outsourcing strategy. This is something that I think that there needs to be an agreement upon, first of all, the architecture. Because if we agree upon an architecture, then we can actually say, we can't do this thing right now, let's outsource that. And if I build things from a functional depiction and I understand that that's the way that I'm going to approach it, then I can actually say, I can't do this, I'm going to outsource it for now. They're going to handle it. I can define the interactions with them in terms of my various functions. And then basically, when I get mature enough, I can maybe look at bringing that back in, or I can just see that that outsourcing is actually a strategic approach. It's a cost-effective approach, and we'll stick with it. MSSP is Managed Security Service Provider, is the acronym that's in there. Another thing that I think that you really need to think about is the idea of what is your topography? And how are you managing the prolific growth of that topography? You have to keep up with the fact that all of these different IT systems are actually out there. And one of the things that the SOC is actually responsible for is tracking the defensive topography. And if you are good at tracking defensive topography, and you start seeing a system internally communicating with something on the cloud that you don't understand what it is, you can actually depict the problem very effectively to your steering committee. Look, we're trying to have well-managed systems. All of a sudden, this thing over here starts up and is doing a whole bunch of stuff for our IT resources that we don't understand. And I can't actually bring my full capability of defense in a place where I do not have a well-managed system. And so this is what you're trying to do. Just put things in two buckets. Well-managed systems, everything else. Everything else represents some unknown risk to us that I actually can't even see inside of that. And we know that this is where we're going to start from, but we're trying to move more things into the well-managed bucket and move things out of that no insight, no visibility, no understanding, no defense. Having this notion of good foresight, consistency, and self-discipline is something that, again, most SOCs don't start with the here's how we're going to self-assess on an ongoing basis. I just gave you 2 free resources. I mean, I didn't give them to you. I identified 2 resources that you could have known about previously and have applied a self-discipline of this is how I'm going to address this problem of my own failures, my own incapability, my own sort of missing functions or technology or process or procedure, or even the identification of the things that I'm missing. But a lot of people are much happier pointing out other people's issues than their own. And so having some sort of self-assessment plan and following up on it and actually deploying it is incredibly powerful. Couple of things that I've talked about here. I mentioned this slide deck being available. It's also available inside of here. That mgt517.com/SOC has a whole bunch of other public presentations that I've done. Additionally, if you pop up in the directory structure, you will be inside of my public resources of stuff that I've shared publicly intentionally. A lot of times people are like, whoa, there's a lot of stuff there. It's like, yeah, there's a lot of stuff there, and it's actually all intentionally shared. So I'll get to questions in a second. Montans.com for me, and I actually have an ask for each one of you. And this is something that would be incredibly valuable to me, is if you take the SOC survey, and I literally finished releasing the questions this morning, I would also appreciate it if you share it with your peers in the industry. I would like to get a lot of people who work in security operations taking this survey. This is incredibly valuable data to share. I have actually written for the last 3 years the SANS SOC survey. This year, SANS decided not to do it, and so I'm actually going to do it independently. It is not sponsored, and at the end of the data collection period, I will release all of the data which is not identifiable back to anybody. Darsh is saying, what about threat hunting and use cases development? There's actually a talk in this link, the mgt517.com/SOC on use case development. There's another one on threat hunting. Threat hunting to me is the sort of research and development and ad hoc component related to monitoring. In terms of use case development, I actually have a program that I think in terms of use case development, one of the outputs that can come from threat hunting is proposals for use case development. Use case, in my opinion, is an engineered sort of implementation of something that the organization cares about. This should also tie back to your steering committee in terms of selection and identification of priorities for use cases. In terms of hunting, this is where our analysts should actually be doing creative work. In the banter before the presentation, I talked about the talk that I'm going to do at Wild West Hacking Fest, which is specifically around threat hunting and my ideas about how to do threat hunting, and some materials that I have that I'm planning to release at Wild West Hacking Fest in order to be able to actually do threat hunt. Essentially, the stuff I want out of a threat hunt is actual detects, scripts, and other sort of operational things, ideas for use cases, and people just practicing good thinking aspects and giving them an opportunity to do that. And some people say, well, should I have a hunt team or whatever? In my opinion, the way that I approach things, I think that everybody hunts. Everybody hunts. It's part of the creative expression of the thing that you're seeing on your role every single day there are opportunities where you could look for improvements, and hunting is the expression of you having the time to go and make that minor improvement. So I think that we're running up to the end here. I provided a bunch of links. There's a ton of stuff in that mgt517.com/SOC. This is something that I think is valuable to a lot of people. There's a lot of ammunition that you can go and share with folks back in your organization. And again, if you would do me the favor of socializing this SOC survey URL, if you go to that, there's a link to a Google form. It's a long survey. It's like 20 minutes long, but it's super useful. And that data is incredibly valuable. And you can go download the last 3 years of papers that I've written on it, and I'll write another one this year as well. Any questions? Oh, thanks.
Chris, yes, thank you so much. I have one question for you from the GoToWebinar. Can you talk about virtual remote SOC setup? Any major differences with traditional on-premise SOC?
Yeah, awesome question. The thing that I usually am most concerned about in terms of virtual remote is legal implications of moving data from one jurisdiction to another jurisdiction. I think that there are concerns that you have in terms of the people that can be overcome, but I don't think that you can overcome jurisdictional restrictions that you have to be really careful about. And so that's always sort of my biggest showstopper for that. Otherwise, I have found so long as you get good people and you have good communication channels among your SOC staff, virtual remote stuff can work just fine. Moving it out of Europe or parts of China or whatever, you start to run into these things that you can't actually overcome. So just be really careful about that.
Yeah, great answer. You covered pretty much all of the other questions that were asked, so well done.
Thank you.
Yeah, with that, we will say goodbye. Thank you guys so much for joining us. Again, sorry you did not get to see us today. We missed.
I had my shirt off too. It was pretty awesome.
All right, thanks, Chris. I'm going to go ahead and close it and end for all.
Right.
All right, bye, guys.